Hi there, this is Mr. Hall, and this is a quick video on how to do equations for the combustion of alcohols. This will be suitable for students doing the IB Chemistry for Unit 10. If you're doing A-Level or GCSE or another course, then it will hopefully be useful for you too. So, combustion of alcohol. So, the links to the IB, it's for Unit 10.2, and it's related to functional group chemistry, and it's all about the application and skill of writing equations for the complete combustion of alcohols. Before we go into that, let's just talk a little bit about how this ethanol fuel is actually made in the first place. So you usually start with like sugar crops, or you can use corn, and these crops are basically the sugar in them is fermented. Okay, so we go through a process of fermentation where the glucose in it ferments in order to create ethanol, which is C2H5OH, and it also releases some carbon dioxide. That process gives you ethanol, or bioethanol if you like, and then this ethanol can be used as a fuel for transport, usually in cars. So this is a petrol station from Brazil, and Brazil is one of the kind of leading countries where they use ethanol quite a lot as a main source of fuel in their transport, so they're protected if there's a slump in like the oil market or something like that. So very, very useful fuel. So the question is, in this combustion process, how do you balance these equations? Well, before we go any further, let's just talk about combustion just really quickly. Combustion is a reaction between a fuel, in this case ethanol or any other alcohol, and oxygen gas. Now, if the fuel's an alcohol and the combustion is complete, the product will be carbon dioxide and water. Now, as an example, we're going to go through the combustion of methanol. And methanol is CH3OH, and it reacts with oxygen, and methanol is over here, the CH3OH. Now, when they react, the bonds have to break, so they're kind of in a kind of temporary state where they're just kind of floating around before making new bonds. And it looks a bit like that. And when they reform, they're going to make carbon dioxide and water. Now, you'll notice I've drawn two molecules of water because I had to make sure that my hydrogen's balanced on both sides of the equation. Despite doing that, I still have a problem because I've got the right number of carbons, but I don't have the right number of oxygens. You can probably see that on the left-hand side there's only 3, but on the right-hand side there's only 4. This is an issue, so in order to fix that, I'm going to actually add another methanol molecule on the left-hand side. So I add that, like so, which is great because now my hydrogen, well not my hydrogen, my oxygens are now balanced, but now the problem is that my hydrogen and my carbons aren't. So to fix that, the carbons first I'll fix, so I'm going to add another carbon dioxide, and I also need to fix the number of hydrogens, so I need to add 2 waters. Now if I do that, I'm going to have a problem with oxygen as well, so I had to actually add 2 more oxygens too, in order to get the whole thing balanced. So it will look eventually like that, and you can see that it all now balances out. I've got 2, 4, 6, 8 oxygens here, 2, 4, 6, 8 oxygens here, I've got 8 hydrogens. Over here I've got 2 lots of 4, 8 hydrogens, I've got 2 carbons, and here I've got 2 carbons as well. The whole thing balances nicely. Now when you're balancing equations like this, really similar to how you balance alkane combustion equations, follow CHO, which I talked about in a previous video. Now CHO's really straightforward. You balance your carbons, you balance your hydrogens, and you balance your oxygens. You might need to play around a little bit to make sure you tidy up and check at the end. As an example, let's go through methanol again, just doing the process without the drawing. So methanol is CH3OH, and this is combusting, so it's reacting with oxygen. The products are always the same with the combustion of alcohols. It's always going to be CO2 plus H2O. Now the first thing I would do if I had this is I'd try and balance my carbons. So I've got 1 carbon here and 1 carbon here, so carbons is fine. Next bit's hydrogen. I've got 4 over here and I've got 2 over here. So this clearly needs sorting out because it's got less than over here. So I need to double that up. And now I've got 4 hydrogens and I'm okay. The last thing I need to do is oxygen. So oxygen wise I've got 1, 2, 3. Over here I've got 1, 2, 4 because I've got the 2 there. So I've got too many oxygens on the left hand side, so I need to get that number up in order to make it 4. So I've got 1, 2, 3. I need another, instead of being 2 I need it to kind of be 3, so I need to multiply that by, I think it's going to be 3 over 2. Now that's 1.5 effectively, so 1.5 times 2 will equal 3, and then adding the 1 will give me the 4, and then that will balance as being a 4. Now as you may remember from my previous video, you don't really want like fractions and decimals in your numbers, so what we're going to do is we're going to double the whole thing up. And when we double the whole thing up, it looks a lot better. So this will therefore, I'm just going to do an arrow there to show that I've doubled up. It will be 2CH3OH plus, now that's going to be times by 2, so it's now 3 lots of O2, and that's going to make 2 lots of CO2 plus 4 lots of H2O. And if you compare this equation to my picture, 2 lots of CH3OH, check, 3 lots of O2, check, 2 lots of CO2, check, 4 H2O, check. So it all balances out. So you still follow CHO, you just got to be a bit careful. We'll do another one, we'll do ethanol. Now ethanol is C2H5OH, and similar to what we've done in our previous questions, we'll add the oxygen, the carbon dioxide, and the water. Now for this one, again I'm going to do my carbons first. I notice I've got 2 over here and only 1 over here, so we need to put a 2 there, so my carbons are now balanced. Next step is hydrogens. I've got 5 plus 1. People often forget that, you've got to be really careful. So it's 5 plus 1, which makes 6. And on this side I've only got 2. I want this to be 6, so a number that multiplies by 2 to give you 6, that's 3 I believe. And now that works. Finally I've got to do oxygens. So I've got 2, let's do the left hand side. I've got 1, 2, 3 over here. I've got 4, 5, 6, 7. 7 over here. So I need to have 4 more on this side. So I believe if I put a number 3 there, 3 times 2 equals 6, plus 1 equals 7. And that all works out. So let's just double check our numbers. 2, 2. Hydrogens are 6, and this is 3 lots of 2, which is 6. Oxygens, 6 plus 1 equals 7. 3 plus 2 lots of 2, which is 4, equals 7. That's balanced. This is a nicer example where you don't have to do any doubling up. That's a better question. Okay, let's try a couple more. So this is hexane 1-ol. You can pause the video before you want to go forward with this example if you wish. So for hexane 1-ol, it's C6H13OH, and again it's the same thing as before. I add the oxygen first, and then I do the CO2 plus H2O. First thing is the carbons, right? I want to balance that first. 6 over here, there's only 1 over here. I need to fix that, so I'm going to put 6 there. That's now 6. Hydrogens, 13 plus 1 equals 14. Over here I've only got 2 as usual. So I need to change that to 14 by adding a 7, because 7 lots of 2 is 14. They're now balanced. Let's now do the oxygens. 1 plus 2 equals 3. Over here I've got 6 lots of 2, which is 12, plus 7, which is 19. Now this is tricky. I need to have a number here which multiplied by 2 and plus 1 gives me 19. Now I believe if I put a 9 there, 9 lots of 2 is going to equal 18, plus 1 equals 19. So I think that works out. So if I just get rid of that and then add 20, I think that works. Let's just double check our numbers. 6 lots of carbon, good. 6 lots of carbon, good. 13 plus 1, hydrogen makes 14. 7 lots of 2 is 14 hydrogen. Oxygen wise, 9 lots of 2, 18, plus 1, 19. 6 lots of 2, 12, plus 7, 19. It balances. Alright? Let's try one more. Now this is slightly different because it's a diol, which means you've got 2 alcohol groups on it. In theory you could have that. It still goes through the same combustion process. So I start off with C2H4OH2 plus O2 makes CO2 plus H2O. Okay, let's get this balanced out. First off, our carbons. Carbon over here is 2, over here is 1. To fix that, I need to double that up, and now it's 2. Next one, hydrogen. Now I've got 4 here, and inside this bracket I've got 2, because that's 1, and it's 1 lot of 2. So 4 plus 2 equals 6. Over this side, I've only got 2. So I need to fix this, so a number that's multiplied by 2 to give me 6, I believe is 3. So that's now balanced because my hydrogens are now 6 on the right as well as on the left. Oxygen, on the left hand side I've got 2 plus 2 here because it's 1 lot of 2. So that gives me 4. Whereas on this side I've got 2, 4 plus 3 and that gives me 7. So I'm not balanced, so I need to fix this side to make it work. So this has to be a number that multiplied by 2 and plus 2 gives me 7. So if I do, let's have a think about this. If I do 5 over 2 of that, that should give me hopefully enough. So that would be 2.5 times 2, which is 5, plus 2, which is 7. So I think that actually works. Alright, now let's just, because we've got another fraction here, we have to double the whole thing up. So if we double up, and then we're going to check our numbers one last time. So one lot of that, therefore to double up we need 2 lots of C2H4OH2 plus, double that up makes 5, because I'm just getting rid of the 2. And that makes 2 lots of 2, which is 4 lots of CO2, plus 2 lots of 3, which is 6 lots of H2. Oh, let's just double check our numbers. 2 lots of 2 is 4. 4 over here, carbons, just double check that's good. 2 lots of 4 is 8 hydrogens, plus these 2, but it's like 2 lots of 2 is quite complicated, so that's 10 I believe, because you've got 4, 5, 6, so that's 12 in total. And over here I've got 6 lots of 2, which is 12, so the hydrogens are balanced as well. And then finally oxygen. On this I've got 1 lot of 2 times 2, which is 4, plus the 5 lots of O2 here, which is 10, so 10 plus 4 is 14, I think. And over here I've got 4 lots of O2, which is 8, plus the 6 from here, and that also equals 14. So that works. A bit more complicated with the dial. You'd be pretty unlucky if you get that as a question. So I hope this has been helpful, and best luck with the rest of your balancing of combustion equations with alcohols.